Hi guys, myself MANOJ.M. Welcome back to the MANJULA.K MANOJ.M YouTube channel. Guys, yeah, in the last video we have made the NAND gate schematic, that symbol and the DC and transfer characteristics. Yeah, in this video we are going to discuss about the NOR gate. Yeah, in this video we also make symbol, schematic, transient analysis and DC analysis. Before that, let me discuss some part of the theory and then move on to the Cadence software to do all of the things. Okay, let's begin the video. Before, if you didn't subscribe my channel, please subscribe my channel and hit the bell icon. Yeah, guys. Yeah, let me initially write this as CMOS VLSI NOR Gate. Okay, let it be look like this, and then come here and let's write the symbol of the NOR gate symbol. Okay, we know that the NOR gate symbol we write like this. Yeah, let me connect it. Okay, this is A, this is B, this is Y. Y is equal to A plus B whole bar. Okay, then here let me write the truth table. Okay, here you know that A, B and Y 0 0 0 1 1 0 1 1. Okay, yeah, we know that the NOR gate output is simply the complement, that is opposite. If 1 is there, we should write 0. If 0 is there for the OR gate, we should write it as 1. Here we know that 0 plus 0 whole bar is 1 and all the remaining things are, yeah, we know that are 0 0 0. Okay, yeah, let me write the schematic here. Yeah, schematic. Here the addition symbol is there. For that we know that the NMOS should be connected in parallel. Let me write like this. Yeah, this to the ground, and yeah, we know that the substrate need to be connected to the ground. Yeah, we have connected the substrate to the ground. Let me write this symbol, and this may write it as A, and this write it as B. This is the gate, this is the source. Here also this one, source, drain, drain. Yeah, we know that we need to do the opposite in the PMOS side. Yeah, since these two are in parallel, yeah, we know that here we need to write the PMOS transistors in the series. Yeah, right. Okay. This is A, this is B, this is VDD, and this is the GND. Okay. Yeah. Yeah, then we know that from here we need to put it to the substrate to the VDD, and this one to also to the VDD. Okay, substrate. Yeah, we know that this one is the source, this one is the gate, drain, source, gate, drain, this one is the drain. Y is equal to A plus B whole bar. Okay. Yeah, all the things are done, schematic, symbol, and the truth table. Let me move on to the Cadence Virtuoso software and do that the schematic, symbol, transfer characteristics, and DC characteristics. Guys, yeah, let us move to that Cadence. Yeah, then we know that we need to click on the terminal, that Virtuoso, and we need to type and then press on enter. It will load. Yeah, it will take some time. Yeah, it came, and then we need to click on this file tab and then click on new and then click on save view and choose it as VLSI. Okay, then give the name as NOR. Okay, and then click on enter. This will open. Yeah, it takes time for the schematic to open where we need to do the schematic of the NOR gate representation. Yeah, let me make to the full screen and then press on high here. Then click on browse. Then click on GPDK090 and select the NMOS and then click on symbol and then close it. Then hide it. Yeah, we know that we need to place the two NMOS in parallel. Okay, yeah, we have placed. Then click on escape, then again click on I, then click on brush, then click on PMOS 1V, then close this, then hide this. Yeah, we know that we need to place this in parallel. Yeah, these things. Then click on escape, then click on W and then from here connect to the here. Okay, then this move to the ground part. Yeah, we know that. Then click on W. Then from here to here, yeah, we need to connect it. And then from here to here, we need to connect. Then click on escape. Yeah, we know that the substrate to be grounded. Yeah, click on W from here to here and then enter the escape. Then click on W here from here to here. Okay, then enter the escape, then click on W from here to here, and then click on W here and move to this above. Okay, these things are done. Yeah, we need to connect it to the VDD. Then, yeah, let's make the pin afterwards. Connect to here. Okay, then click on W. Then move slightly this side and connect it to here. That's it. Okay. And then let us make the A, B and the strings. After we select the pin, then click on escape, then click on P button. A, B, VDD, GND, then click on enter. Okay. A, let's place here. B, let it place here. Okay. Then VDD, yeah, we know that it should place here. And then GND, let us place here and click on escape and then click on W. Then connect this. Then yeah, click on W. Connect to this. Then for B, click on W. Connect to this. Okay. Yeah, this is A as we write. Yeah. Then click on W from here to here, connect this. Then again click on W from here to B, connect this. Then click on P. Then make it as output and give the pin name as Vout. Then click on enter. Then come here, click on R, it will rotate. Then click on escape. Then click on W. Then connect this to here. Okay. Yeah, all the major things are done. Then click on check and save. Yeah, there were zero errors and two warnings found. It is showing as, let me find where is the error. Yeah, let's see. Yeah, we have not properly connected this time. These things sometimes happen. Connect here to here, then click on escape, then again click on check and save, then minimize it, then again check on this if there is a something warning like that. Schematic check completed with no errors. VLSI not schematic saved, it showing like this. Okay, then let's click on F. Yeah, then maximize it and then yeah, we need to create the symbol we know. Then click on create and then click on cell view, then from cell view, yeah, then click on OK. We know that the input pins, that means we as usually put the input at the left, yeah, A and B, and we know that VDD is the top pin. Cut this and then again place this here, then put the G and D here, okay, then click on OK. Yeah, it came. Yeah, let me here give the name as NOR Gate, NORGAT, okay. Remove that the instance name, okay. Then enter on the check and save. It will automatically correct, okay. Then minimize this also, minimize this. Then click on file, then click on new to verify the outputs, then click on save view. Then give the name as NOR1, that's it, then click on OK. After that, maximize it, then click on high, then click on brush, then click on VLSI, then click on NOR, choose this symbol and then close and then hide. Yeah, place this here, okay. Then click on escape, then click on P, it will be in the output. Give the name as weird, then click on enter, then click on R to rotate, okay. Then click on, then again click on P, then select this as the input and then give it as A, B, VDD, G and D and then hide this A here, B here, then click on R, VDD here and then G and D here, then click on escape, then click on W, connect here to here, then click on W, connect here to here, then click on W, connect from here to here, then click on W and connect the VDD, okay, then click on W, connect the V out, okay. Then click on check and save. There were 0 errors and 2 warning from it is coming like that because yeah, I thought I had connected these things, but yeah, sometimes the mistakes happen. Click on W and then connect here to here. Yeah, we have faced this 2 times. Yeah, in the schematic part also we faced, and in the that verification part using the symbol we are also the facing the same mistake. Yeah, I'm not edited. Yeah, let's the mistakes happen. When the mistakes happen, we need to verify that. Yeah, I thought I had connected everything. I simply skipped the schematic check completed with no errors. VLSI NOR1 schematic saved. Yeah, then to verify the output, click on launch and then click on ADEL. Then click on this symbol. Okay. Then we know that the ground, the DC voltage is 0. Select DC, make it as 0, then click on apply, click on enable this thing and then click on apply, okay. Then come to the VDD, then click on enable, then click on this and move to the DC and then give it as 1 and then click on apply, okay. Then come to the B, okay. Then make it as pulse and then give the voltage 1 as 1 volt, then the period as 40 nano, then the pulse width as 20 nano. Then click on enable, then click on apply, okay. Then come to the A, then make it as pulse and then voltage 1 is 1 volt and voltage 2 is 0. Let it be 80 nano and 40 nano. Okay, that's it. 80 nano, this pulse width is 40 nano. Then click on enable. Then click on apply. Then click on OK. Then move to the outputs. Then choose to be plotted. Select on schematic. Then click on A. Then click on B. Then yeah, I am finding that weird. That's it. Yeah. Then click on this analysis. Then click on choose. Yeah. first, yeah, let's do the transfer analysis. Select stop time as 200 nano. Select on moderate, then click on OK. Then run this. Yeah, it takes some time to run this. It is loading here. Yeah, the output came. Let me click on this. Yeah, we have know that. Yeah, we know that the output should be 1 when the both the inputs are 0 0 from the truth table. You can see that. Yeah, the same thing is happen when the inputs are 0 0. It is 1. It is happening due to the delay. That's it. There is some delay in the circuit in that area that's moving upside and then come down. It happens every time. Okay, there is little bit delay in the circuit. Yeah, if you see in this period, this move to one, this thing is happening. In otherwise, majorly it's not happening when there is a delay. This time happen. We you can call this as glitch also. Yeah, let me close this for the DC characteristics. We know that. Yeah, let me maximize it first. Okay. Yeah, let me delete the A and B these terms. Okay. Click on this, right click and then click on delete. Yeah. Then click on W. Okay, connect from here to here, then click on high, then click on browse, then click on analog lib. Okay, then type here V pulse. Okay, V pulse, then click on close, then make the voltage 1 as 0 volt and voltage 2 as 1 volt, then the period as 14 nano, and then the pulse width is 20 nano. Then hide this, then place this here, then click on escape, then click on W, connect here to here, then click on W, connect here to here. Okay, that's it. Then click on escape, then click on check and save. See if there is error exists or not from here. Yeah, majorly no error would be exist, but yeah, you should check that right when you click on check and say schematic check completed with no errors, VLSI nor schematic saved. Yeah, let me delete all these things, A, B and V out. Okay, delete and delete. Let's disable this transient analysis, then click on analysis, then click on choose, then yeah, let me click here. Yeah, it's maximized it. Choose whether it's there or not. Then click on DC. Then click on the save DC operating point. Then click on the component parameter. Then select on component. Then select this component and select on DC voltage. Then click OK. Yeah, then start as 0 and stop as 1. Okay, then click on OK. That's it. Yeah, then come to here and then click on outputs, then to be plotted, then select on schematic, then click here. Okay, then click on the Vout. Okay, then run this. Yeah, it takes some time. Yeah, you have seen the output of the DC response of this NOR gate. Yeah, we have made the schematic and then made the symbol and see the transient response and DC response of the NOR gate. Yeah, I hope this video helped you. If you found this video helped you, click on like button. Please subscribe to my channel and share with your friends. If you have any doubt or confusion regarding this doing the circuit or something else, you can comment in the comment section. I will reply as soon as possible. Thank you for watching guys. See you in the next video.